Hi, welcome to one more video on recap of control systems. In this video, uh, we will basically look into modeling of electrical and mechanical systems. So, for which you should be knowing these many things. It would be easy to understand the content of this video if you know these things. Okay, with these prerequisites, let us move on to uh, finding what is the transfer function of uh, this particular uh, electrical circuit. So now we know that we can replace resistor capacitor by their Laplace representation. So this R1 remains R1. This C will be 1 over S C1, and this is R2, and this happens to be 1 over S C. So now this is V in, this is V naught. We are asked to find what is V naught of S by V of S, the transfer function. So for that, let us reduce this parallel combination. Let us reduce this series combination. Let me say ZS, the series combination, as R2 plus 1 over S C2. So this will become, if I take, so this as, so this will be S R2 C2 plus 1 by S C2. So this is the simplification. So that P, that is, this will become, so it will be, it's like, okay, a parallel combination of this and this is, so this into this divided by this plus this. So this into 1 over XC1 by R1 plus 1 over SC1. So this happens to be R1 by SC1 by, this is SR1 C1 plus 1 divided by SC1. So this will go with this. So this will become R1 by 1 plus SR1 C1. So this happens to be ZP. So this is, this can be rewritten as, this is ZP and this is ZS. This is V naught. So V naught by V in is nothing but ZS by ZP plus ZS. So ZS is nothing but this impedance. So what is V naught of S by V in of S? So where it, this is ZFS, it is, yes, R2 C2 plus 1 divided by SC2. That what is ZFS divided by what it is, this is ZP, R1 divided by 1 plus S R1 C1 plus of ZS is S R2 C2 plus 1 by S C2. So these two are the terms in the denominator. Okay, let me just simplify this. This becomes, so V naught of S by V in of S is equal to 1 plus S R2 C2, okay, divide by SC2 whole divided by, let me take, since it is plus is there, I can write it as S R1 C2 plus of 1 plus S R1 C1 multiplied by S R2 C2, okay, this is plus 1 whole divided by S C2 1 plus S R1 C1. So this will go with this. this will get multiplied. So ultimately this will become 1 plus S R2 C2 into 1 plus X R1 7, because this will go over here, this will go over here, divided by S R1 C2 plus S, you just multiply this, S R2 C2 plus 1 plus S square R1 R2 C1 C2 plus S R1 C1. Upon simplifying, this is 1 plus S R1 C1 1 plus S R2 C2 divided by A square R1 R2 C1 C2 plus S into R1 C1 plus R2 C2 plus R1 C2 plus 1. So this is V naught of S by V naught of S. Of course, no need to write the signal flow graph at all for this. So you can straight away solve this because it is very easy. You have this parallel combination, this is series. So replace this by ZP, replace this as ZS. You know what is ZS, ZP. We know that this is like a potential divider. It is ZS by ZP plus ZS. So just substitute them. Just please don't stop it here. Please don't stop it here. Bring it to this form so that now you have, of course, you have a quadratic equation. If you know the values of R1, C1, you can actually predict the pole and zero position. So let me just do that also. So let me take for this particular example. So let us try to identify the poles and zeros of this. So let me take this as okay, 10 kilo ohm. This as maybe 1 microfarad. Let me take this as 1 microfarad. Let us take it as okay 10 ohm. So this is 10 ohm. So let us substitute the values of okay R1 C1 here and then try to now if you can see uh, zeros at minus 1 over R1 C1 and minus 1 over R2 C2. So that what is zeros. The poles are, let me solve this equation. So it is square into, so what is R1 R2? It is 10k into 10 into 1 micro into 1 micro plus s into what is R1? It is 10k into 1 micro plus 10 ohm into 1 micro plus R1 is 10k, 10k into 1 micro plus 1. Let me find the values of this. So it is 10 exponential 3 into 10 into 1 exponential minus 6 into 1 exponential minus 6. It's actually n square e minus this 10 power minus 7 plus of s into what is what 10 exponential 3 into 1 exponential minus 6 plus 10 exponential minus 6 plus 10 exponential 3 into 1 exponential minus 6. So the value is 0.0201 plus 1. So the roots of this are, so let me find the roots of it. It is 1 e power minus 7 is A, B is 0.02001, then it is 1. So roots are minus 49.98 and the other one is minus 200.0, sorry, 1000. This is 0.05, this is minus 200.050k, this is 49, correct. And if you can come to this zeros, so the zeros are at, so what is R1? R1 is 10k. It is 10 exponential of 3 into 1 exponential minus 6. 1 over that is 100. So it's like minus 100, and it is 10 into 1 exponential minus 6 equals 1 over that is 10,000. Sorry, 100k. This is 100k minus 100k. So now if you look at this, these are poles. The poles, these are zeros. Zero is at, okay, one of the pole is at minus 49.8, almost 50. Then there is a 0 at minus 100. There is a 0 at minus 100k. There is a pole at minus 200.050. This is the poles and zero position of this circuit with these values of R1, C1. See, we can actually find the exact location of poles and zeros if you know the values of R and Cs. Just putting this, we may not get the clear idea of that. When you actually substitute the values of R and Cs, we can exactly locate the pole position in H-plane, poles and zero position in H-plane. So maybe you might have learned in the later part of the control system, this is actually lag lead network. This is a lag lead network uh, having certain function in the compensation network. So this is the pole zero position. So this is how you can able to find it. Let's do it for one more such problem. So let us do it for, you can just do for this also, just for the curiosity. You can just, again, you have, this is a series combination, ZS becomes R1 plus 1 over SC1, ZP, the will become R2 into 1 over SC2 by R2 plus 1 over SC2. The way how you write RA into RB by RA plus RB. In place of R you have R2, in place of RB you have this capacitance which is 1 over SC2. Again it is RA is like R2, RB is like this reactance. Okay, this is V0, this is Vin. So what is V0 by Vin? It is nothing but, suppose if you rewrite that circuit as this is ZS and this is ZP. Why it is P means because this is parallel, this is series. S is the representation of series. So this is V0, Vin. So from this it is ZP by ZS plus ZP. Just varies from circuit to circuit. This is this. So now this, what is this? This you can write it as, I think you can write it as, this is R2 by 1 plus yes R2 C2. That's what we can write it as. This is what is that? What is ZS? ZS can be written as 1 plus S R1 C1 by S C1. Okay, let us substitute here. What is ZP? ZP is R2 by 1 plus S R2 C2. What is ZS? It is 1 plus S R1 C1 by S C1 multiply, sorry, plus of ZP is R2 divided by 1 plus S R2 C2. This is what I have. So this, when you simplify, take the LCM and all those stuff, so this will become, in the denominator it is 1 plus S R1 C1 2 1 plus this is S R2 C2 plus R2 SC1. In the numerator, this will cancel with this. You'll end up with SR2C1. Correct? So this will be now SR2C1 because this will go off. Divide by. So, because you can simplify this, it is 1 plus SR2C2 plus SR1C1 plus square R1 R2 C1 C2 plus SR2C1. So this ultimately reduces to SR2C1 divided by a square R1 R2 C1 C2 plus of S. Take the S as common factor. It is R1 C1 plus R2 C2 plus R2 C1 plus 1. So this is the transform. If you again substitute the values of R and C, you can see you have a pole at you have a zero at origin, and of course you'll be having two poles somewhere on the real axis depending on the values of R and C. So this is what you will end up with. You can see interchanging the position. This is actually series and parallel. Here it is parallel series. So this has yielded in uh, something like this as the pole zero position, whereas this is yielding something like this. So this is yielding something like this. This is having zero at origin and of course two poles depending on the values of R1, R2 and C1, C2. Okay. So this is how do we proceed, and then let us try to see this problem. How do we find V naught of S by V n of S? The previous two problems we didn't use any signal flow graph method to find the transfer function. It was very straightforward. To find the transfer function of a bit complicated circuit diagram, something like this, so we may have to use the signal flow graph for that. So let me take this loop current as I1, this as I2, and this as I3. Let me consider this as some V1 node voltage. Now let me try to write the equation for each of the variables, each of the dependent variables, and then try to form the uh, signal flow graph. So I can write what is, let me list out the variables. So this is Vin, you have I1, you have V1, you have I2, you have I3, you have V0. So this is an independent variable. So whereas I1 is a dependent variable, so I1 can be written as Vin minus V1 by R1, whereas that is this current. The current flowing through R1 is I1, which is nothing but Vin minus of V1 by R1. That's what it is. So V1 is a potential that is drop across this. The current flowing through this is I1 minus I2. So it is I1 minus I2 multiplied by the impedance of this. Impedance is 1 over C1. So what is this I2? I2 is a potential difference. V1 minus V0 divided by the impedance. So divided by the impedance divided by 1 over SC2 will become multiplied by SC2. Then what is I3? I3 is in this loop is nothing but V in minus V0 divided by R2 plus S11. S11. So what is the series combination? And V0 is nothing but this drop. So V0 is I into I into one slight mistake. I'll tell you what I'm doing, what I've done. So let me just come back to that. So what is this? This is I2. This is this is the current that is flowing. It is I2 into R2. Basically, when you see this I1 is not what is the current that is flowing through this? It's actually I1 minus I3. So I have to do here I1 minus I3 is equal to this. That's the current flowing. And here, what is the current flowing? It is I2 minus I3. So I have to write this as I2 minus I3. So this is the change I have to make. So then what is I1? I1 is actually equal to V in minus V1 by R1 plus I3. What is I2 is equal to? I2 is equal to V1 minus V0, V1 minus V0 into SC2 plus I3. This is my I2 expression. I hope you got the mistake there. The current flowing through this R1 is not only I1. So it's actually this current is I1, whereas this current we assumed as I3. So typically the current flowing through this is I1 minus I3. Here it is I2 minus I3. So that's why I have to write I2 minus I3 as potential difference divided by the impedance. That's what it is. So now once you're done with this, identify the variables. It is V in, I1, V1, I2, I3 and V0. Or let me write I3, I2, V0. You can write any order, it's fine. So now what is this? So I1 is, you can see here, what is I1? It's V in 1 over R1 and it is, this is minus 1 over R1 and you have I3 coming directly. This is I3 which is 1 now, correct? Then what I have some more terms. What is V1? V1 is nothing but I1 into 1 over SC1 and it is from I2 it is coming, it is minus 1 over SC1. Next, what is I3? I3 is actually this, it is got right, this is so I3 is V in, the value is 1 over R2, so 1 over R2 plus SL1. So this is the magnitude of this, and then it is you have this V naught also minus 1 over R2 plus SL1. Correct. I3 is done, so we are done with I1. I1 is done, V1 is done, I3 is done. How about I2? So I2 is what? I2 is equal to V1. So this is actually SC2 and this is minus SC2 and I3. I3 is actually going positive. This is one. Correct. Then what is V naught? V naught is I2 into. So this is. So you need to identify now the loops. So this is loop 1. This is loop 2. Can you see this is loop 3? Can I have this as loop 4? So can I take what else? Do I have any other loops? This. I hope those are the three loops. I think you have forward paths. One is this, other one is this. There are two forward paths. Now, of course, you can. This is a very random circuit, so just to have so what Mason's gain formula is nothing but V naught of S by V of S is nothing but 1 over delta okay, summation of E is equal to 1 to K, okay, 1 to K is equal to 1 to N, where is where is Pk delta K, where N is the number of odd parts. So N is equal to actually 2 now. It is this and this. So you end up with P1 delta 1 plus P2 delta 2 by delta. So delta is nothing but 1 minus of how many loops are there? We have L1 plus L2 plus L3 plus L4 plus of non-touching loops is L1 L2 plus L1 L3. I think that's it. This two are not touching, this two is not touching, this is touching, this is touching, this is touching. So what is delta 1? Delta 1 is, if you consider this as P1, all the loops will touch. So this will touch, this will touch, this will touch. So if 1 1 is 0, how about delta 2? Delta 2 is this won't touch. It is 1 minus of P1. This goes like this. And you can easily write what is L1 product of this, L2 is product of this, L2 is loop gain of this, L4 is loop gain of this, and you can do the simplification. So I'll just leave it at this point so that you can exactly write the transfer function of V naught of S by V of S is given by so and so. It's given by it's P1 delta 1, it is P1 delta 1 plus P2 delta 2 by delta. So delta is this, P1 is 1 over R1 into L1 into SC2 into R2. Then sorry, P2 is, so it is 1 over R2 is L1 into 1 into R2. So that's what is second part. Write the corresponding delta 1 and delta 2. This is how we can able to use signal flow graph, for which for writing such type of equations you should know the Ohm's law, and then try to write of course you should know, you should be knowing how do we write the nodal voltages and loop current equations. Once you're done with that, you can easily plug in the equations to form a signal flow graph, and then writing the equation to get the overall transfer function in terms of forward pass, individual loops, non-touching loops, and delta 1, delta 2. Next, we shall move on to one more circuit where you can just think of bit complex circuit. So I can take this as this, or maybe a capacitor here. So what is V naught? Something like this. You cannot solve the complete circuit here. It is R1, R2, C1, C2. I want to know what is V naught. This is V naught. So let me write this as the loop current. This is the loop current I1. This is the loop current I2, and this is V naught. Let me say this as V1. Let me say. So now we have the variables V in, I1, I2, V1, V0. This is a independent variable. So now you have I1 minus V2 is equal to V in minus V1 by R1. So this is what is this current flowing through this is I1 minus I2, which is given by this. But I2 is V in minus V0 divided by the impedance of this. It is SC1, and V1 is the current that drop across this. So it is I1 into okay, 1 over SC2. What is V0? V0 is actually this current multiplied with this resistance, which is nothing but I2 into R2 plus V2, because this drop is sorry, plus minus this drop is I2 into R2, and this voltage is V1. So if you write the HFG of this, V in I1 V1 I2 V0. What is this? Using this equation, it is 1 over R1, it is minus 1 over R1, this is 1 over SC2. Okay, I have to write this will go there. There is a I2 coming from here. This is plus 1. Okay, this when it goes onto this side, I can just take out this, write it as I2. That's what is this I2. Then what is I2? I2 is V in into SC1. This is minus SC1. And what is V0? V0 is this is V1 and correct. So you have loop 1, loop 2. These are the loops. Levels. This is a loop. If I start from here, I can go like this. This is other A3. Here, I can start from here, go up, come down, go like this. So you have three loops. L1 is minus 1 over S R1 C2. L2 is minus S R2 C1. L3 is 1 over S C2 into 1 into 1 into minus C1 into 1. So this will become minus of C1 by C2. This is A3. These are the three loops. Non-touching loops are, okay, let me come to that. So how many power paths? So P1 is, this is 1 over R1, 1 over SC2 into 1. So this is first power path. Second power path is P2 is SC1 into R2, correct? Any other path? It is this. Next it is, I think that's it. And what is delta 1? Delta 1, this is the forward path. So it's like 1 minus 0. What is delta 2? Delta 2 is, so this is my second forward path. So this doesn't touch. It's 1 minus of, okay, 1 minus of minus 1 over S R1 C2. Minus of minus will become plus. So what is delta now? Delta is equal to, okay, 1 minus L1 plus L2 plus L3 plus of non-touching loops are L1 L2. Okay, if you want to write the expression for this, you can certainly write it is 1 over S R1 C plus of S R2 C1 multiplied by 1 plus 1 plus 1 over or 1 plus 1 over S R1 C2 whole divided by 1 plus 1 over S R1 C2 is L1 plus S R2 C1 is L2 plus this C1 by C2 plus of L1 L2. L1 L2 is sorry L1 L3 sorry L1 L2. Okay, it's plus of 1 over S square R1 R2 C1. Okay, this will be the equation. So I can simplify this. So this is now 1 over S R1 C2 plus of S R2 C1 uh, into 1 plus 1 plus R S R1 C2 divided by S R1 C2. So R1 C2 is common here. It will become S R1 C2 divided by 1 plus 1 plus S R2 C1 plus S R1 C2 plus S square R1 R2 C1 C2 whole divided by, so it is, if you take the LCM of this, so you will have S square R1 R2 C1 C2. So this remains S square R1 R2 C1 C2 plus S R2 C1 plus what will happen? So this will go off. Mm, you'll have some more terms. Okay, now because you can simplify this. I'll leave it to here if people at this point. Because it is always better if you have the values of R1 C1 given, then it is easy to locate the poles and zeros. You can certainly solve for this and then try to get an expression for the poles and zeros. Make sure that it is something like S plus Z1, S plus Z2, and S plus P1, S plus P2, some poles, some zeros, some poles, and maybe some root locus gain is there. So you bring it to that form. You bring it to this form. So the intention of us trying to show you how to solve this is, because this is not in terms of examination point of view what I'm telling you about. I'm talking about how do you write the what equations of these dependent variables and how do you form the signal flow graph, and ultimately how do you write the Mason's gain formula to write the transfer function of this system. This is the transfer function. Then next is the simplification part of this. Correct. So this will become again plus of. So what will happen to this? So you will end up with S into R1 C2, and then this C1 will go off. Of course, I'm just continuing there. Plus of A square R1, you will have C1 square R2 plus 1. So this is what the denominator is. Then you can just, that will go there, that will end up with, so what do you end up with now? So it is 1 plus okay, A square plus A square R1 R2 C1 C2 plus S into R2 C1 plus R1 C2 plus 1 whole divided by, so when this goes up there, so this is entire thing is multiplied by S R2 C1. Denominator will have okay H square, because we don't have H square R1 R2 C1 C2 plus A square R1 C1 square R2 plus S into R2C1 plus R1C plus 1. This is the overall transfer function V naught of S by V in of S. If we can see here, this is of course if you multiply this also you will end up with a transfer function given by, so these are your poles and zero positions. If you plug in the values of R1, R2, C1, C2, you'll get the poles and zeros at the respective positions, at respective positions. Okay, so then let us move on to uh, okay, we shall move on to the mechanical system in the next video. So these are all examples of electrical system with different RNCs identified, and of course even the inductors also be there in the circuit diagram. So we'll see in the next video for mechanical systems.